Okay, so where we left off was me telling you, go to this chart, look up fresh water, and when you do, you will see that its speed in fresh water is 1,482 meters per second. Okay? So then come back over to the question. And put in right here 1,482 meters per second. And now find the time that it takes to go the whole way. And when you do, you will get 0.0472 seconds. So it doesn't take very long, not even, that's like 1/20th, less than 1/20th of a second for it to go down and come back. Because remember, we doubled the 35 because the 35 was just one way. All right, question number 5. You want to estimate the length of a large sports complex. You generate a loud noise at one end of the stadium and hear the echo 1.2 seconds later, and the temperature is 12 degrees. So the sound goes down and comes back, and the delta T total is 1.2 seconds. And it tells us the temperature is 12 degrees. Sounds like our gym. It's always cold in there. How far away is the far wall? So again, this is down and back, so either you need to divide the time by 2 now, or when you get the distance, divide it by 2. So first, though, you have to use your 331 meters per second plus your 0.59 meters per second degrees Celsius to find your speed. So that's 12 degrees that goes in there. And when you do this, you get a speed of 343. No, that's wrong. 338. 338.08 meters per second. And then you go and do VAV is equal to delta D over delta T, and we're solving for delta D. So delta D equals VAV times delta T. So if you choose not to divide first, it'll be 338.08 meters per second times that 1.2 seconds. And this will be our delta D total then if you do not divide first. And so you get 405.696 meters. So delta D one way will be half that, so 202.848 meters will be the length of the sports complex. All right, 1 to go. Number 6. Number 6 says, how long does it take sound to travel 2 kilometers in air at a temperature, at a temperature of 22 degrees. So 22 degrees, so 331 meters per second, 0.59 meters per second degrees Celsius, times 22. V is equal to 343.98 meters per second. So now you're looking for how long does it take it to travel. So VAV is equal to delta D over delta T, how long you're solving for delta T. So delta D over VAV. And it said 2 kilometers, so that's 2,000 meters, divided by 343.98 meters per second. And when you do this, you get a time of 5.814 seconds. Okay, so that's part A. That's for sound. Part B now asks for light. The speed of light is 3 times 10 to the 8th meters per second. How long does it take light to travel 2 kilometers? So in B, again, VAV is equal to delta D over delta T. Again, delta T is equal to delta D over VAV. But this time, it's 2,000 meters still on the top, but 3 times 10 to the 8th on the bottom. And when you do the math, you get a much tinier number. It is 6.6 repeating times 10 to the negative 6 seconds. Now, really, for us, that would be instantaneous. We wouldn't be able to tell that time. Okay, so light can travel 2 kilometers instantaneously, whereas sound takes almost 6 seconds. And that's how one can figure out if a storm's getting closer or not. Thunder and lightning. When you see the flash of the lightning, if you start to count slowly, like so, 1 steamboat, 2 steamboats, 3 steamboats, so there's a second, or Mississippi if you're American. So there's a second pause between your numbers. Then every 3 seconds is a kilometer. And so as you count in the summertime in a thunder and lightning storm, you can tell how far away the storm is by how far apart the thunder is from the lightning. If they're instant, if you see the lightning and then hear the thunder, and that's usually when we have like a massive heart attack, it's because the storm's right on top of you. So you can tell if the storm is getting closer by doing the counting each time, or if it's getting further away. So if the thunder and lightning are closer together, the storm's approaching you. If they're getting further apart as the storm goes on, then it's going away from you. And lots of times it'll approach and go by us. And so anyway, just so the next time you're in a thunder and lightning storm, you're thinking of physics. There is a part C. It says the rumble of thunder is heard 8 seconds after a flash of lightning, and the temperature is still 22 degrees. How far away is the church? Because the lightning hits the church. So we can assume that the lightning is going to get there instantly. And so really we just need to find out how long does it take us to hear the sound. And so again, VAV is equal to delta D over delta T. Delta T is equal to delta D over VAV. But this time it tells us, oh wait, how far away is the church? We're really solving for delta D. Delta D is equal to VAV delta T. Okay, so we found our temperature for 22, our speed for 22 degrees earlier. It was 343.98. So we're going to use that. 343.98 meters per second. And it says it's heard 8 seconds. So if what I just said to you, that 1 kilometer is about 3 seconds, we would think this would be slightly around 2.6 repeating. And when you do it, it's 2.751, oh, not a point, 84. 2,751.84 meters. So when I say it's about 3 seconds a kilometer, remember the speed of sound changes depending on the temperature. So that's not a hard and fast rule, as it'll be closer to exactly 3 seconds a kilometer if it's a little colder than 22 degrees. Here, because it's 22 degrees, it travels a little bit faster than that. Okay, so there's your homework questions. Next video will be some stuff on sound, okay? So please watch. Thank you.